to work with circuits with independent sources. The problem is to find the current I1 in the circuit shown below. The circuit has two independent sources. It has a current source on the left-hand side, which is 2 milliamps, and has a voltage source at the top of the circuit, which is a 3-volt source. So the first thing that we do when we're doing a nodal analysis problem is we identify the nodes. So let's do that first. We have a node 1 on the left-hand side at the top, a node 2 at the right-hand side at the top, and we have a reference node, which is our 0-volt or ground node at the bottom of the circuit. So now we would then write the nodal equations about those nodes using Kirchhoff's current law. And in this case, we're going to sum the currents into the nodes. So if we do that for node 1, we can see that node 1 has 3 currents flowing into it. The current from the 2 milliamp source, the current up through the 3K resistor in the center leg of the circuit, and the current through the 3-volt source on the top part of the circuit. So if we add those currents up, we would find that we would have an additional unknown current associated with the 3-volt source. We have no way of determining what that current's going to be through the 3-volt source as it stands. So whenever we have a voltage source which is tied between two nodes, where one of the nodes is not a ground node or a reference node, we have to use the concept of supernode analysis. And so in this case, what we're going to do is we're going to identify our supernode as the node which encompasses node 1 and node 2 and our voltage source, our 3-volt source. So this is our supernode. We can then write our Kirchhoff's current law equation about that supernode as one of our independent equations. So let's do that. So we have our supernode, write an equation summing the currents into the supernode. We have a current 2 milliamps flowing in, we have a current up through the 3 kilo ohm resistor, and we have a current up through the 6 kilo ohm resistor on the right hand side. So summing those currents, we have 2 milliamps flowing in. For the 3K resistor and the current through the 3K resistor, it's going to be the ground node minus V1 divided by 3K plus the current up through the 6 kilo ohm resistor, which again is a ground node minus V2 divided by 6K. And that's equal to 0. So we look at our supernode equation, we see that we have two variables, V1 and V2, the nodal voltages for node 1 and node 2. So we need another equation which is independent of our supernode equation to solve the problem. So we can write an additional equation which relates V1 and V2 with the voltage drop between those. And it's our constraining equation. 3-volt source is plus to minus as designated in the problem. And so we have V1 minus V2 is equal to 3 volts. So we have our two equations. Ultimately, what we're looking for in this problem is we're looking for the current I sub 1 flowing down through the 3 kilo ohm resistor. So really what we're most interested in is finding V1, because looking for I1, we know that I1 is equal to V1 minus 0 divided by 3K. V1 minus 0 divided by 3K. So if we can find V1, we can find I1, which is what the problem is really about. So looking for V1 using our set of two equations and two unknowns, we get a V1 equal to 5 volts. If we find V1, plug that back into our equation for I1, then we have I1 equal to 1.67 milliamps.